All right. Now we're on to the notes for today. The notes for today are actually going to be the scenarios we were looking at yesterday. We had just started looking at the pumpkin dropped from the 9.40 meter roof. We all ran this calculation. We had a math prediction. That math prediction was based on this equation. We wanted to figure out the time to get to the bottom, the time to drop. We had that equation we had up here. The distance to drop over 5, square root the whole thing. We plugged in the distance it was dropping, 9.4 meters. And then we did our calculation, just like the two skill drills, 9.4 divide 5, do that first. 9.4 divide 5, do that first. So 9.4 divide 5, 9.4 divide 5 gives you 1.88. Then you square root, and it gives you 1.37 seconds. Time is seconds. Now, your prediction time to bottom. Now, this is an important one. Okay, we're actually going to watch a pumpkin drop from a roof. Now, here's what I want you to understand. You look at this here. This we had yesterday. And today, I want you to continue it. Let's put a little comment right here. Every single student is in the same exact position on this, no matter which class you're in. Okay, this is a continuation. Continuation. So this right here, what you're going to see below, this is CU3 notes day. Let me see. 15/16, depends on which class you're in. And this is for, yes, Thursday, 2/25/21. Day 15 is for period 9. Day 16 is for period 1. So you're one day apart, but you're doing the same notes. So your notes begin here, and it should be right beneath the equations we had written yesterday. All right, so your prediction, time to bottom, explain. Here's the thing about it. Let's put a little note here. You can write this as well. Let's go good size. All right. Ready? Here's the note. The math prediction, which we wrote up top, does not include air resistance. This is real important to recognize. The math prediction, these equations up here, do not include air resistance. They do not think about air. So now I want you to make a prediction. Your prediction. And here's what you're going to write. I predict that the pumpkin will take, you're either going to write, you have three choices here. More than, equal to, or less than 1.37 seconds to hit the ground because, and you're going to answer this. Okay? Let's see here. Put space in there. Good. You're only picking one of these. You're not picking all three. You either think it's going to take more than 1.37 seconds. You either think it's going to take exactly equal to, or not exactly, let's say roughly equal to 1.37 seconds, or you're going to say it takes less than 1.37 seconds to hit the ground. By the way, if you're wondering what 9.40 meters is, that's basically the height of our classroom window. So if you need a little time to catch up on this writing, then pause the video and write this. That's all. Okay, so if you're still listening, you must have completed this comment already. You've unpaused. And now the actual time to the bottom, let's see what it is. That's what we're going to do on these. We have three scenarios. You're going to make a prediction. You're going to do the math. You're going to make your prediction, and then you're going to do the actual. Actual time to bottom, let's see. Let's pull up this video. Here it is.
Hurry up! All right. Watch out, Angela. You can move.
So here I'm dropping a pumpkin. This is actually the roof over the middle, or the shared wing. They used to call it the shared wing. But it's about equal to the height of our windows. All right, so let's zoom up to the action. Here we go.
2, 1.
There it goes. Okay, so let's back it up. And let's see if we can figure this out. Now, it's a little hard to get exactly. We've got to get when I let go. I let go right around like there. I don't know if my hand is still touching. We do this with a frame count. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 7, 8, 9, 40, 41 and change. 41. It's not a full. There's 40, 41. Maybe I give it like 41.3 or something. Okay, so you may say, what are you talking about 41? All right, what you can do with a video, which we've talked about before, but I'm going to help you guys on a little later on. Oh, undo that. We had all those nice colors. Okay, what you can do here is, here's what we're going to write. From the video, it took about 41.3 frames to hit the ground. Okay, fine. This is equal to, how do you turn frames into time? Well, this may be something that you guys have only heard briefly or don't know too much about. A lot of people don't know too much about this. 41.3 frames. What we do here is you have to divide by the frame rate. The frame rate of the camera that took this is 30 frames per second. Okay? And if you divide these two numbers, 41.3 by 30, 41.3 divided by 30, I actually got 1.3766. It comes out to about 1.38 seconds. It's a cool way to take a video. You can do this on your phone. You take a video and get a time from it. It's actually a pretty cool thing. 1.38 seconds. Wow. That's pretty dang close. We predicted 1.37. It was 1.38. Wow. I mean, how could this be? I kind of wish I was in class and we could all talk up ideas for this. But this time almost equals the predicted time. What does that mean about air resistance? Well, it seems like the pumpkin pushed through the air easily over 9.40 meters. Seems like there was almost no air resistance for the pumpkin over that short distance. That's pretty cool. Okay, pause the video if you need to catch up. All right, let's go over here. Now we got a next one. We're going to do a basketball drop from a 140-meter dam. Whoa, math prediction. We want the time to the bottom. All right, you're going to write this one. You can do this. Math prediction, time to bottom. We have an equation to get the time to the bottom. Here it is. It's the same one we just used. You would say time to drop. I'll just put a little d for drop. Time to drop equals big square root the distance to drop over 5. There it is. Boom. Okay. And so then you have to substitute. That's not so hard to do. Time to drop equals square root. The distance to drop in this case is 140 meters. And this one is over 5. And you got to do your math here. You do 140 divided by 5 first, and then you square root it. So the time to drop here is going to be, so this is really like the square root of, what's 140 divided by 5? It's 28. So we think the time to drop should be about square root of 28 That's 5.29 seconds. Okay, good. Now you have to make a prediction. Now 140 meters is a little farther than 9.4 meters up here. In fact, I'm going to give you a link to the video. I'll put it in the assignment. You'll see it there. Here's the video. And so this guy drops
We're here at the Gordon Dam, and what we're going to
this
do is
basketball from this 140 meter dam. It's pretty cool. Now the way you're going to get time on this, you can do it a couple of different ways. You could either look at the clock time here, or even better, just use your stopwatch. Use a stopwatch on your phone and just watch, when he lets go, you hit start, but be ready with it because it happens quickly. Like start, and then you'll see when it hits, stop. However, it doesn't even hit the ground. It hits kind of farther up. But anyway, let's get back over to this business. Your prediction, the time it takes to hit the bottom. So you're going to make a prediction here. Your prediction is going to be formulated the exact same way as the last time. Remember, the math prediction does not include air resistance. So you're going to come down here. I predict that, this time it's not a pumpkin though, I predict that the basketball will take more than, equal to, or less than, and it's not 1.37 this time, it's 5.29 seconds to hit the ground because, and you have to give an explanation here. The actual time to the bottom, I'm leaving this one on you. I was going to have you do 3 videos, forget it, we're doing only 2. The one I showed you, I walked you through the whole thing. The second one is this one. Actual time to the bottom. So here, watch at about, I think it happened around 0:27 into the video, and time it. Then explain the result. I'm going to want you to do a second thing as well. So this is an instruction for you. You're going to have to write what happened, just like you did before. The time almost equal to predicted. Well, you'll see. It's going to be more or less or equal. And you also have to think about the fact that it didn't even get all the way to the ground, as we saw. I also want you to watch. He does it again. This time at about, let's see. Okay, at about 58 seconds, he does it again, and he spins the ball this time, which is pretty cool. Let's see if it changes anything. So put a comment on this. Watch at about 0:57 also. This is now a separate answer. And explain this, actually, and time it. Then explain this new result. You don't have to get fancy in your explanation. If you watch the video, he gives it a name and whatnot. You could give it a name. It's only like a 3-4 minute video. But you just talk about air a little bit. It's a pretty cool thing. That's it. That's the whole lesson there. You're going to analyze those 2 videos, and that's it. Then tomorrow we're going to try something new. Good.